Computer science videos here today to show you guys in this tutorial of operating system concepts. Part 1, the overview. Chapter 1, introduction. Computer systems architecture. And so now we can speak on how a modern computer system actually works with a diagram and then explain the diagram. So we need a CPU, we need a device, we need memory, and then we need to bring all the components together. Within CPU, we need cache, C for cache, CPU, thread of execution, I/O request, the data, and the interrupt. I'll just write all this on the bottom. D for data, and I for interrupt. DMA, device, memory, instructions, and data. Data movement. Instruction execution cycle. And so the I/O request goes from the CPU to the device. The data can go from the device to the CPU and vice versa, as well as the interrupt. And DMA, which stands for direct memory access, can go from device to memory and vice versa again, back and forth. Hence the double arrows on cycle, data management or data movement, DMA, data, interrupt. And so now we can explain the whole diagram, what is really happening. So storage is only one of many types of I/O devices within a computer. A large portion of operating system code is dedicated to managing I/O, both because of its importance to the reliability and performance of a system because of the varying nature of the devices. A general purpose computer system consists of CPUs on screen, multiple devices, controllers that are connected through a common bus. Each device controller is in charge of a specific type of device. Depending on the controller, more than one device may be attached. For instance, 7 or more devices can be attached to SCSI, which is Small Computer Systems Interface. A device controller maintains some local buffer storage and a set of special purpose registers. The device controller is responsible for moving all the data between the peripheral devices that it controls and its local buffer storage. Typically, operating systems have a device driver for each device controller. This device driver understands the device controller and provides the rest of the OS with a uniform interface to the device. So, to start an I/O operation, the device driver loads the appropriate registers within the device controller. The device controller in turn examines the contents of these registers to determine what action to take, such as read a character from the keyboard peripheral. The controller starts the data transfer from device to its local buffer. Once the transfer of data has been completed, the device controller informs the device driver via an interrupt, which is I, that it has finished its operation. The device driver then returns control to the operating system, possibly returning all the data or a pointer to the data if the operation was read or not. For other operations, the device driver returns status information. This form of interrupt-driven I/O is fine for moving small amounts of data but can produce high overhead when used for bulk data movement such as disk I/O. To solve this problem, we then have DMA, which is direct memory access. After setting up buffers, pointers, counters from the I/O or for the I/O device, the device controller transfers an entire block of data directly to or from its own buffer storage to memory with no intervention by the CPU. Only one interrupt, yes, is generated per block to tell the device driver that the operation is done and thus it has been completed, rather than the one interrupt per byte generated for low-speed devices. While the device controller is performing these operations, the CPU is available to accomplish other work. Some high-end systems use switch rather than bus architecture. On these systems, multiple components can talk to other components concurrently at the same time and perform other tasks rather than competing for cycles on a shared bus. In this case, DMA is even more effective, and this figure that we have on screen shows the interplay of all components of a computer system. So, in this tutorial, we spoke about how a modern computer system works. CPU, device, memory are all interconnected to one another. That's it for this video. I'll see you guys in my next tutorial. Thanks for now.